Hi everyone. My name is Adedeji Fabiyi from Computer Science Department. And in this section, I'll be talking about the use of Science Gateway to execute jobs on different DCIs. The evolution of distributed systems has ensured that scientists have an infinite number of resources to run their jobs and get their jobs in good time. However, the adoption and use of these resources can be quite daunting and can drive potential users away from adopting this technology. So in order to access this technology, in order to access resources, scientists often have to deploy their own software, which is seen in command line interfaces, job description languages, management of personal digital certificates. So the question then is, how do we ensure that potential users are not deterred from adopting this technology? So we introduce the concept of Science Gateway. What then is a Science Gateway? A Science Gateway is a digital interface to advanced technologies which can be used to support science and engineering research and education. These Science Gateway are often implemented in in mobile and web as mobile and web application, and they can be used to support access to community resources such as high-performance computing, sensors, instruments, and data repositories. Who needs a Science Gateway? A Science Gateway will be used by community of practices, different community of practices that might have to access resources such as high-performance computing, high-speed communication network, powerful communication networks, and make use of sensors and stuff like that. Then it might be used by community of practice that might want to collaborate between their peers within the same scientific domain or across different scientific domains. So what specific application to port to a Science Gateway? For the purpose of demonstrating how a Science Gateway can be used to run jobs and execute jobs on different distributed computing infrastructures, we have developed an infection model which has been implemented using Repast Symphony. Now, the aim of this simulation is to show how an agent-based simulation can be used to study the behavior of infections with an annual outbreak by using appropriate input data. Now, there are different factors surrounding this model. We have the infected agent, we have the susceptible agent, and we have an infected agent. And in that premise, when an infected agent comes in close proximity with an infected agent, with an healthy agent, then it becomes susceptible. And then over a period of time, it becomes infected. Then they form an infection network. So how can a Science Gateway be used to support our agent-based simulation application? In order to develop a Science Gateway for community of practices, we have to start by identifying needs, their special needs for that specific scientific domain. So for our agent-based simulation model, we know that a simulation needs a way to input data, needs a way to upload models and to perform some sort of execution. Then it needs a way to collect output and perform interpretation as well. So all these special requirements must be made available and facilitated on a Science Gateway. So what method have we used? We have in order to make sure that scientists are able to run their jobs without having a full knowledge of the details of the underlying infrastructures, we have adopted an approach which is known as the Catania Science Gateway Framework. Now, this framework has two distinct interfaces. It has one interface which exposes APIs and softwares to the Science Gateway, and it has another interface to the different DCIs, which is known as the JSAGA. JSAGA stands for Java Implementation for Grid Access to Applications. So when a user wants to log on to this, to our Science Gateway here, it takes them to Identity Federation and Identity Providers, which is a service that checks to see if a user is who they claim to be. And if the logon is successful at that level, the Science Gateway checks another registry to check for roles and privileges that a user might have. And from there, based on the roles and privileges, they are taken to the applications that the user wants to see, which in our own case is the infection model. So what happens within a distributed environment? Like, how is our agent-based application, how will this application be executed in a distributed environment? Now, with the knowledge that, with the requirement that many simulations need to be executed in a reasonable amount of time. So the question then is, how do we keep execution time manageable while scaling up to increasing number of agents? So we come up with different ways of looking at it from the DCI levels. Now we have we could have P number of jobs, one simulation each. Then we have N virtual machines with one core. Then we try to sequentially find a way of mapping our P simulations to our N virtual machines. Now, building on the first one is an improvement, which leads to the second one. The second one is we have P jobs. We have P jobs, one simulation each. Then we have N virtual machines and M cores. Then we try to find a way of parallelly mapping the P jobs to our M virtual machine, to our N virtual machines with their M cores. Then the third one is because of the processes that is involved, we won't actually see the effect of the job we're trying to run. So we won't go into those ones. Now, the outcome and result is the Science Gateway that gives a way of helping users to input their data, their input data, and then from the picture, they can click on the submit button, and when they click on the submit buttons, it runs on whatever DCIs has been configured with the Science Gateway, and then users can collect their result and then use an infection model visualization tool that is on the Science Gateway as well to see their output. And in summary, we've given an example of how a Science Gateway can be used to execute jobs on A infrastructures. And then we've used an agent-based simulation application as a case study. Then we can think of other applications within our domain as well that this kind of method can support. Thank you. Any questions?